Today, we're going to take a journey, not to some far-off place, but deep inside the high-tech maze of a modern coal power plant. We're going to follow the path of dirty flue gas as it gets transformed into something clean off to meet some of the toughest environmental standards on Earth.
And really, it all boils down to this one huge question. Can you actually do it? It's a question engineers have thrown billions of dollars and decades of work at trying to answer. So today, we're going to see just how far the technology has come. Okay, let's get into it.
And look, we're not just talking about any old plant. We're diving into the design for a brand new facility, one that's engineered from the ground up to meet incredibly demanding European-level emission standards. This isn't just theory. It's about hitting very specific, very hard targets. And here they are. These aren't just suggestions. They are the absolute, non-negotiable legal limits. Every single piece of equipment we're about to look at is there for one reason, to get the emissions below these numbers. So the big question is, how on earth do you pull that off? Well, you do it by creating a gauntlet. Seriously, think of it like a massive, multi-stage obstacle course. The hot, dirty gas has to run this gauntlet from the second it leaves the boiler until it's finally clean enough to exit the chimney. And each stage in the course is designed to snatch a specific pollutant out of the stream. And here's our map for that journey. Right out of the boiler's intense heat, the gas is going to get cooled, zapped with electricity, scrubbed in a massive chemical shower, and then reheated before it ever sees the light of day. This is the exact path we're going to follow, step by step. All right, our first stop, our first challenge is the most visible one: dust. Engineers call it fly ash. We're talking about microscopic bits of soot and ash that can cause some serious health problems. And there is a ton of it. And when I say a ton, I'm not really exaggerating. Get this. The gas coming straight out of the boiler is carrying up to 40,000 milligrams of dust for every single cubic meter. That is 800 times higher than the legal limit. It's just an incredible amount of solid stuff floating in the air. So to deal with this, engineers have a big choice. Option 1 is the electrostatic precipitator, the ESP. It's basically a giant dust magnet, using powerful electric fields to pull the particles right out of the gas. Option 2 is a fabric filter, which is more like a gigantic industrial-scale vacuum cleaner with these huge bags that physically trap the dust. For this particular plant, the proven, cost-effective choice was the ESP. And the result? Whoa! Check this out. It goes from 40,000 milligrams all the way down to less than 30. That is a removal efficiency of over 99.9%, an absolutely massive success for the first stage of the gauntlet. The gas is now clear, but believe me, it is far from clean. Okay, with the dust gone, the gauntlet now takes aim at an invisible enemy, harmful gases. Specifically, we're talking about sulfur dioxide, or SO2, which is a major cause of acid rain. So as the gas enters this next stage, it's still carrying around 1,800 milligrams of SO2 per cubic meter. That's still more than 20 times the legal limit we have to hit. So how in the world do you wash a gas? Well, you build a giant chemical shower. It's called a wet flue gas desulfurization unit, or WFGD for short. Inside this huge tower, the flue gas gets blasted with a slurry, a mix of crushed limestone and water. That limestone kicks off a chemical reaction that literally captures the sulfur, turning it into a harmless byproduct called synthetic gypsum. And that chemical reaction works like a charm. The SO2 level just plummets from 1,800 milligrams down to less than 60. That's a removal rate of over 96%, which puts us comfortably below that legal limit of 75. Okay, 2 stages down, 1 major hurdle to go. So the final pollutant is a really tricky one: nitrogen oxides, or NOx. These gases are a key component of smog, and they're not great for our lungs. And what makes them so tricky is that unlike dust and sulfur that come from the coal, NOx is actually created by the intense heat of the combustion itself. You have to fight this one at the source. And this is where modern boiler design is just so clever. Instead of creating a huge mess and trying to clean it up later, engineers use special low NOx burners and carefully inject air to prevent most of the NOx from ever even forming. Just by doing that, these primary measures slash NOx levels by more than 2/3, getting the plant really close to its final target right out of the gate. After conquering dust, sulfur, and NOx, the gas is almost ready. It's clean, but there's just one last finishing touch. It passes through something called a gas heater. This just reheats the clean gas enough to get rid of that visible steam plume you sometimes see, and it also protects the chimney from corrosion. But cleaning the air is only half the story. A truly modern plant can't just move its pollution problem from the air into its wastewater. No, it has to manage every single drop of water it uses, ideally in a completely closed loop. And that brings us to this incredible concept, zero liquid discharge, or ZLD. The name says it all, right? The ultimate goal here is to design a system so good that not one single drop of industrial wastewater ever leaves the property. And this is what that system has to do. I mean, it handles the whole shebang. It collects all the different wastewater streams, the stuff from the sulfur scrubber, from the boiler, the cooling towers. It treats it, filters it, and purifies it until that water is clean enough to be used again right back in the plant. The only things that leave are clean water vapor and solid, dry salts that can be disposed of safely. So let's bring it all home. This table, this is the final scorecard, and it perfectly summarizes the whole journey. In the middle, you have the strict legal limits they have to meet. And on the right, you see what the system is actually designed and guaranteed to achieve. On every single pollutant, there's a significant safety margin built right in. This is what it takes to run the gauntlet and win. So we've seen that it is technologically possible to burn coal and meet these incredibly strict air and water standards. What we've looked at today represents the absolute peak of what's possible. So the final question really isn't about the technology itself. It's about its role, its cost, and its place in our energy world as it continues to change. What does all this mean for our future? Well, that's something for all of us to think about.